Welcome to the inaugural episode of the Telepath Expert Systems Interview Series. My name is John Juhasz. I'm the founder and CEO of Telepath Systems. Our focus is on generally examining some of the vital issues of our time, like energy, mobility, infrastructure, etc., and then seeking ideas for advancement through collaboration, education, and systems engineering. We're here today to discuss a new initiative in education. It's called Microgrid Systems. We're very pleased today to have with us David Long. I consider him a leading visionary and a systems thinker, practitioner, a pillar of the SE community of INCOSE, is the International Council on Systems Engineering, and David has been the president, a leader for a long time. It's a privilege to have David here. Just want to say a few words about Telepath Systems. We are a nonprofit enterprise. We have been organized for about 12 years around three basic pillars. One of them is collaboration. That includes a focus on conferences. We have been running and managing conferences under the name of Energy Tech in the past for about 10 years, which included a lot of support from INCOSE and NASA and some other organizations, including SAE International. We have modified the title to Energy and Mobility, and along the way, Dave has been a major contributor to our cause. He's been a keynote speaker a number of times. Second pillar is education. We want to leverage the outcomes that we create at these conferences. That we're very happy to receive many of the excellent speakers and their contributions, and convert that to an education opportunity. We'll talk a lot more about that today. And the third pillar is the category of systems development, engagement with communities, project management, consulting, etc. But let me just a few words about myself. I'm a longtime member of INCOSE. I started back in 1991. David, as you know, I knew your father well. He was one of the outstanding leaders and thinkers at the time, and I took some classes that he taught on RDD 100. Of course, later that became Core and Vitech, and I'm sure you'll say a few words about that. But I just want to mention that my interest and my passion for systems engineering started when I was working on at NASA on the International Space Station. Back in the late 80s, early 90s, it was a tremendous challenge. At that time, it was considered the most complex system ever developed by humankind, and it was indeed. To build something like that in outer space was truly a challenge. So I really began to understand and appreciate the need for looking at the whole, the integration of different elements to contribute to the function of the whole. So I joined INCOSE at the inception in 1991, Chattanooga. For over 30 years, David has helped organizations around the world increase their systems engineering proficiency while simultaneously working to advance the state of the art. David is an internationally recognized leader within INCOSE and the greater system engineering community. He works with government and commercial organizations as they assess, adopt, and deploy methods and tools to enhance their engineering enterprise. I want to just point our viewers to this website, which is the International Council on System Engineering INCOSE website link. So, David, I'd like to ask if you can expand a little bit further on your bio. I wanted to get your take on your background. Again, I had great respect for your dad, Jim Long, and how you started Vitech and how that's evolved to support our concepts of engineering and so on. Would you take a minute on that?
Yeah, absolutely, John. So my story is a little unique because I am the son of a systems engineer. So while my father, Jim, never set out to make me a systems engineer, the way he languaged the world caused me to develop a strong systems thinking mindset. And by that, I mean, most of us are taught to think about things, the individual parts. The way my father languaged the world was all about the interactions between things. And so before I even really knew what a systems engineer was, I knew I wanted to be a systems engineer. So immediately out of university, I actually took my university undergrad and graduate projects and turned them into an organization called Vitech Corporation. I had developed software At that point, we would have called it a CASE tool, computer aided systems engineering tool, software to support systems engineers capturing their information, visualizing their information, reporting their information, managing their information. I came out of university and created a company to commercialize that technology back in 1992. I had the pleasure of working with my father for 18 years in that company and spent 29 years with Vitek developing Core, its successor product Genesis, but most importantly, helping organizations raise their systems engineering proficiency. As you noted in your opening, this is such an important approach, technique, discipline, whatever word you want to use, as we address the complicated and complex problems of today. So Vitek was focused on that mission, and I remain focused on that through INCOSE and other venues.
Excellent, David. Wanted to ask a thought about where we are today. We have advanced our society to such an extent, our technology drives almost everything we do today. You can't get through the day without touching technology every time you turn around. We have truly come a long, long way in an engineering sense to achieve a lot of the comforts, that civilization requires or demands, etc. However, at the same time, when you look around the scope of things that are taking place in the world today, we seem to be running into so many problems that, in some cases, one could argue, well, it's nature, it can't be avoided, etc. But in many cases, you can look back on retrospectively and say, well, geez, that problem could have been understood or analyzed or maybe improved, but better had there been a little bit of systems thinking, some foresight, perhaps. And I don't want to, name specifics, but there's so many cases of disasters that leave communities devastated in many cases. And I would assume that systems engineering would have exposed a lot of the vulnerabilities we confront today. What do you think is what's going on with our society? Why do we not recognize the importance of systems thinking and avoid the risks that we confront every day?
It's a great question, John. And for me, I think the weakness emerges from a strength. And by that, I mean, if you look at our education system, Western education is designed to make us deeper and deeper experts in narrower and narrower areas. And that has driven technology forward. It's driven societal advances forward. But by getting to be such specialists in narrow areas, we develop tunnel vision and we don't understand the interactions between technologies, the interactions between us and the natural world around us. And so, as we're taking very, very well meaning actions, we have a bit of ignorance beyond our domain, beyond our specialization. And so, if you take a step back and say, well, what is systems engineering all about? Systems engineering is about a couple ideas. First is the idea that the collective intelligence of the many is greater than the singular intelligence of the one. All of us together, if we can blend our insights, are going to be smarter than any one individual. And that's particularly true when we deal with these highly complex issues like energy and mobility, where it's not just one kind of engineer, one kind of specialist. We require many different people, many different specialties to understand problem and solution. And so the systems engineers that I call it a transdisciplinary connective tissue that tries to help get that team talking across their boundaries, amplify the collective intelligence so we better understand the problem, we better understand the implications of our actions, we deliver a better solution, and most importantly, we deliver a solution that not only achieves the outcomes we want, but does so without these unintended consequences, be that pollution, be that risk, be that system failure, whatever. And so the strength comes from our deep knowledge. The weakness comes from our deep knowledge. And so by adding systems thinking, not to replace the other thinking, but to complement that deep analytical thinking, I believe that's how we advance into a better future.
To address some of those kind of challenges, what we've been, I wanted to talk a little bit about the education series I mentioned earlier. We, Telepath, have been in collaboration for better part of a year now, and probably maybe going back several years as a result of our conferences, to work with local university and regional institutions in support of an education program. We're calling it Microgrid Systems. Now, I want to step back and explain a little bit about that. As we've discussed earlier, when you say the word microgrid to people, many times they say, "What?" And then you say system engineering, they say, "What? What do you mean?" It's still a mystery to many why this is such an important thing. But let me encapsulate the problem that we have in the energy sector as I see it. And every day you hear a little bit more now, even in the mainstream media, about the energy problems that we're facing as a society. I would characterize it in three different categories. One, electrons. It takes electrons to move through a wire in order to create electricity and therefore energy. And we are running seriously out of electrons. We got so much demand on the horizon, as you know, from advanced data centers. AI is generating so much demand, as well as on top of that, of course, we got the whole electric vehicle movement, transportation, electrification, it's called. We've got so many issues with other demand, the whole onshoring of manufacturing that's happening now as a result of the tariff imbalance. That's going to require a lot more energy than we've even contemplated yet, still trying to absorb all that. And also, at the same time, as we are lacking in capacity, we also have problems with a lot of resilience issues. The current infrastructure we have, the grid that we have, is very vulnerable to a number of threat scenarios. So I've been involved for a good decade or more with a couple of organizations that focus on infrastructure and resilience of problems of infrastructure. So that's another challenge. At all this time, we also have a problem with the workforce. The workforce needs significant upgrading or upskilling, it's now called. Skilling in order to develop the systems that are needed to support the energy demands. And I would argue there's a third element, and maybe it's the most important one. It's the lack of critical systems thinking, as we discussed before, with all the challenges that are either not understood or not properly addressed. So I think all three of those are contributors to the motivation for our initiative on energy, educating about energy. Microgrid systems is the course. So what I wanted to do is give you a brief overview of the course, the contents, and get your thoughts on it. So we're going to introduce students from industry, people who are seeking to upskill their career knowledge. Also, students entering the workforce, looking for an entry-level position, perhaps in the energy sector. And also, I think an ideal group of candidates is veterans coming out of the military who are seeking to re-engage, re-employ in the private sector. I myself, I'll have to say, I gathered a lot of skills. I joined the Navy before I went to college, and I wasn't sure what career I wanted to follow. But that experience, shipboard experience, taught me a lot about electric systems fundamentals and really motivated me to become an electrical engineer. So I think I see a lot of that kind of an opportunity. What we want to do at this entry phase, first leg of a multi-level education program, is to introduce these students to the idea of what is a microgrid, why is it necessary, how are they going to contribute to the energy problems that we have, solving those problems. But the second pillar is equally or maybe more important, and that is a lot of the systems orientation. We want to teach them about system principles, about how to analyze their stakeholder needs and so on, and about the whole process of life cycle management and development of a system throughout its end life, overall costs and so on. Those are all aspects that we're going to be focused on. So I personally think there's a significant need for this kind of education initiative because it's not really taught that well in many higher institutions. And trying to build a solid curriculum. I know a number of universities have it. Of course, Virginia. I think you went to school in Virginia. They have a very aggressive systems program. But now a lot of other schools don't have that, and they're looking for ways to build the workforce. So we see an opportunity here to combine the system engineering education process with the microgrid systems. Microgrids, as you surely know, are complex systems and they have multiple technologies that need to be integrated to work seamlessly together. And system engineering is the way to ensure that all these components are integrated properly. And those are the key elements of things that we want to educate them on. So my thoughts on this are, we wanted to make sure that there was a strong component of systems, and that would prepare the students also for further knowledge acquisition. And we're already planning the second level, which includes a whole lot of things like model-based methods, digital twins, and so on. And further series are still in contemplation about program management levels and so on. I just wanted to see if you've had a chance to take a quick look at our program. What are your thoughts about the way we're approaching it?
John, I appreciate the way you frame it from the very beginning because all of those levels that you talk about are systems problems, as you well know, from the rising demand, electrification, resilience, green energy, all of that. And so at the higher levels, we can appreciate it as a societal unit and the importance, but the microgrid focus that you have makes it tangible. And as you said, microgrids to be successful require multiple technologies to come together successfully. That is the fundamental definition of a problem space where systems engineering is perfectly suited. You also noted the criticality of through life evaluation, through life concerns from the very front end, understanding all the stakeholders. Who am I not talking to understand their needs so that I can address them effectively up front rather than being surprised at the end? How do we design the system so that it will deliver the needs that it delivers the capabilities that we need, that it can evolve with us because we know power demand is just going to continue to grow. And when it becomes time to retire components, have we designed in such a way, have we engineered in such a way that we can retire in a way that is ecologically friendly, et cetera? So the framing of this, both in terms of the general systems principles, but more importantly, you heard me say earlier that systems thinking is complementary to deep analytical thinking. Systems thinking in isolation is an interesting exercise, but when we combine it with domain knowledge in a particular area, that's when we really unlock the power. And that's what you're seeking to do with this program by bringing the concepts of systems to the specific application domain and the application domain of energy, which is so essential to, well, our near term and long term future. So it's a wonderful initiative, the kind of initiative that we need to see in domain specific systems.
Thank you. Appreciate your vote of confidence in our approach here. Very much appreciate that. I wanted to also emphasize, as I mentioned earlier, and you've been a practitioner for a long time with Vitech, and you've been at the forefront of a lot of model-based initiatives. The use of models in the process of developing a system. I just wanted to emphasize that I mentioned earlier about how far we've come with technology. It was maybe last year or was this year, but I watched a keynote by Jensen Huang. You know, Jensen, he is the head of NVIDIA, now the biggest corporation in the world ever. His message was, and he introduced, of course, with his Blackwell chipset and all the advancements that they've made in the semiconductor space. He introduced these massive capabilities that have been emergent and dormant for a long time because the technology has outstripped our ability to know how to use it effectively. And I think we're still lagging far behind in the use of these tools to help our cause with the understanding and development of systems. So I'm really excited about the idea that we can bring this back into the classroom. Cleveland State sees the future also. Developed a pretty advanced computer simulation lab. So we're eager to exploit that opportunity with the course and to introduce students to the idea of, look, in fact, we plan to, with the help of some of our collaborators, bring in an active project, an active microgrid system architecture design, one that's operating in the field, let the students have at it and disassemble it into its component parts, analyze it, reconstruct it in a model-based environment, and then run potentially simulation studies to see how that model works and how it compares with the real world and so on. So basically, it's going to get them much farther, hopefully advanced with all of the new technologies that are out there. Uh, one of the things that we think is going to contribute to their elevation of understanding is we're going to prepare them for the ASEP exam. That's the INCOSE Associate System Engineering Professional. That's one of our objectives with the first level course. I wanted to ask you to comment a little bit about that. Would the ASEP exam is not trivial. I looked at it and it's a lot of questions, pretty deep, and we expect students are going to have to study up for that. But we're going to help to prepare them, and they'll take that class. I think it will hopefully increase the INCOSE population as well as a result. But give me your thoughts on why do you think getting students oriented along that line with an ASEP certificate could be a career contributor? What does it mean for the individual and also the organization?
Yeah, it's a great question, John. And so I am an ESEP. I'm an expert systems engineering professional. I never had to take the exam. I got old enough years of experience that I bypassed that aspect. But I do encourage individuals who are passionate about systems to pursue the route that you're talking. And so here, where you're making it a natural byproduct, shall we say, of the academic coursework that they're doing, what does pursuing an ASEP certification show? It shows that you have the foundational command of the knowledge necessary to successfully deploy systems engineering. Again, from stakeholder analysis, requirements, behavior, architecture, verification, through life concerns, etc. And so it is that foundational knowledge and the underlying principles that will position the individual for success throughout their career. That's step one, and that is evident through the certification. But there are two other aspects that I think that we often overlook about the value of ASEP or the next level CSEP, Certified Systems Engineering Professional. The first is, as you commented earlier, systems engineering is not well understood as a term. Microgrids are not well understood as a term. Well, if you go tell somebody I'm a systems engineer, they may think that you're an INCOSE type of systems engineer, or they may think that you're a Microsoft Network systems engineer, or any number of other things. There's a lot of brand confusion. So by having the ASEP or CSEP certification, you clearly differentiate your brand and say, I am this kind of transdisciplinary and through life systems engineer, applying that knowledge to microgrids. And the third thing is you're signaling to the workforce, the world around you, that you're committed to your advancement and your investment in yourself to maximize your capabilities, both in systems engineering, but actually in your through life journey, because you've said, I'm going to invest myself in a certification that's important to me. So I think there are a lot of great benefits for you, the individual. That's honestly why I pursued my ESEP. But also then there's benefit to the greater systems engineering discipline and population, because we then strengthen our brand together to say, when we're talking about systems engineering, yes, there are other types. We're not going to denigrate those. But when we're talking about systems engineering, this transdisciplinary true life concern, these are the types of people who are doing it. This is the value that we are delivering as a community. So that ASEP, CSEP, ESEP differentiates the individual, the practice, and ultimately the discipline.
Maybe, yeah, excellent. A thought or two. How about the organization that's seeking to employ, you know, young people full of energy, of course, but also now with some more clarity of thinking? The ASEP provides that. What do you think about that?
Absolutely. Yeah. So it provides the clarity of thinking. It provides a shared knowledge base because the ACEP certification is a certification against a specific knowledge base, and it enables that cross-team dialogue from systems engineer to systems engineer because you've got the common principle, you've got the common language, etc. It doesn't mean that you have to agree with absolutely every idea you've ever been taught, but the ability to collaborate and the ability to advance is founded upon that common basis. So by having a certified population, individual to individual can collaborate better. And we as an organization ABC, we're able to elevate our proficiency in delivering whatever kind of systems that we're talking about, in this case, microgrid systems.
Let me go back and just one more question regarding technology. As I mentioned earlier about Jensen Huang and NVIDIA. If you haven't seen some of those keynotes, they are fascinating.
I
Because
watched the same video that you're talking about. It was last year's video, and it is
right,
fast.
it was indeed, and it blows your mind how much can be done with those technologies, which we have yet to fully leverage. What do you think? You can hardly conclude any discussions nowadays without the term AI. How do you see the integration of AI with model-based approaches to future engineers and what they can expect to achieve with it? I see some companies are already integrating those into their model-based products. To talk a little bit about that, if you could.
So I think the first thing is to take a step back and talk about what model-based means to systems engineers and systems engineering. And I like to frame model-based as applying today's computational capability, both analytical processor capability, but also data storage, to better capture, analyze, compute, store, manage, etc., all the information we require to engineer a complex system, to specify, analyze the architecture, etc. And so it is a approach and a technique to better elicit, capture, and manage that information. Well, if that's true, then you can immediately see two capabilities. First is the moment we have that information, there is an architectural aspect. What does the design look like? And there's an analytical aspect. What is the performance of that design? If you think about an aerospace engineer, if they are engineering the shape of a wing, they can change the shape of that wing and immediately run a computational fluid dynamics simulation to understand how does that little tweak or major change I just made change the lift characteristics and other characteristics of the wing. Model-based systems engineering allows us to adjust the architecture and then immediately see at least a first-order impact of system performance. Wow, what a revolutionary change as you're deploying a capability such as a microgrid. If we then couple that with AI and ML, AI and machine learning are fundamentally about leveraging the underlying data for greater pattern recognition, for greater co-engineering, for greater analytical capabilities, for efficient frontier exploration of the trade space, any number of things. Well, if MBSE structures our information in a more explicit manner, then that means the underlying data that we have to feed AI it has much greater richness, not only for the human, but for the machine algorithms, which just empowers AI to accelerate its capability to suggest better architectures, to suggest refinements, to do tweaks and run simulations to try to find the optimal point on the efficient design frontier. So this combination of model-based AI and then the NVIDIA power set through these chips, powered by the energy backbone, as you said, AI and data centers are demanding a lot of power. This whole system allows us to take our engineering to a different level.
It's really very well said, very well expressed. I love the analogy of the wing and the design architecture, fluid flow, and so on. I think that same principle, as you pointed out, really applies to a new initiative. Microgrids are, for many people, still kind of a new idea. It's not like you can leverage past designs easily and replicate them like you do cars. Every year or two, you have a new car model based on the old model with small iterations and so on. Here, you got a lot of greenfield scenarios. And the other aspect of this is, and that's why it's I think it's a perfect match to integrate system engineering into this discipline, because you've probably heard this expression, by microgrid people. They say, if you've seen a microgrid, you've seen one microgrid, because the next one's going to be different, and the third they're all different based on geographical
Right.
resources. You might want to use geothermal, you might want to use hydro, all kind of different ways of generating electricity. So this demands a real good understanding of that area, that domain, that environment, and then the individual stakeholder needs that you're going to have to satisfy.
At the same time, John, I'll assert, and please correct me if I'm wrong, because I'm not an expert in the field. There's a foundational set of principles that would govern the effective architecture and design of any given microgrid. And
Right.
this is somewhere where the magic of this program comes together, because you're equipping somebody with both the systems engineering knowledge and capability with the domain specific principles so that they can do the right design and bring those analytical concerns, et cetera, together to make the right microgrid for the right circumstance. Am I correct?
I think absolutely, and that's a message we've been trying to deliver to the general community. I personally have to say, in some of my experiences, I've seen people who they're confronted with making decisions about how to proceed with this project, and they are overwhelmed by the number of uncertainties and unknowns and all these kind of things that, well, maybe so, but so and so knows, and we'll kick the can down the road. I have to believe that as they begin to realize the benefits of a model-based approach, they can study all the variations as you described with the flow over a wing, all the design modifications. They can do that before you dig a shovel of dirt having to build anything. You can reduce your risk profile on a project, from a substantial risk to a fairly moderate risk. You can't eliminate it, but you can resolve a lot of the uncertainties of system design, even looking at the economics, the cost, the operational configurations. So all of those things are benefits and advantages that we hope to realize from these coursework, this series.
The old mantra, right, is the biggest mistakes are made on day one of the project. Put that in the positive terms, and what it says is the most important decisions are the decisions made on day one of the project, both the decisions that you explicitly make and then the implicit decisions because you didn't consider X, Y, and Z. And so systems engineering allows us to, by leveraging the right principles, by connecting the right people, to make better early decisions, which pulls down the overall life cycle cost curve. Yes, we're investing in systems engineering, but we're going to have to do less rework, and we're going to deliver a capability that is more matched to the user needs. So again, as we're playing in a complex space such as microgrids, particularly where every microgrid needs to be fit for context, it just further amplifies, well, the reason behind this course that you're developing to highlight microgrid systems, both aspects together.
And I'm very encouraged by all your positive statements, and you've been very supportive. I also want to take a moment and thank you for all the times you've come to Energy Tech, you've delivered fascinating keynote speeches, and I still have them on video if you want them. But I've been in touch with a lot of the INCOSE folks now, including Courtney Wright, about the whole education initiative. So they're very supportive. I'm very glad to have INCOSE, and we are showing INCOSE in partnership on this effort, along with Cleveland State, of course, and the Cleveland Engineering Society, where a lot of members are looking at these advancements that they need for their own enterprises. So I really appreciate your efforts on this, and look forward to further engagements on this. If you have any suggestions along the way, I'd like to have you Give us any counsel that you can. We're happy to engage anytime.
Always will, John. And I appreciate you bringing these bodies together because one of the things that I'll often say is a great systems engineer in isolation, intellectually interesting, but really worthless. The great systems engineer in concert with the right team and the right situation, incredibly powerful because you're marrying that systems thinking with that deep subject matter expertise. You're doing the same thing as you try to bring these groups together in INCOSE, Cleveland State, etc., to try to make the whole greater than the sum of the parts. That's what systems is all about. So I applaud the initiative and I'm happy to help any way I can.
I want to thank you very much, and we do look forward to saving you a slot on the next Energy and Mobility Conference. We're planning that for next year. More to come on that later. But for now, we're focused on this class, and we appreciate your thoughts, your contributions, David. Thanks again for joining us today.
Really a pleasure. Thanks, John.
Thank you.